So knowledge pattern lists kind of link the geometry within the model to something that the pattern can understand. Because although there is an explicit link between these two things, between the model tree and the script, the pattern can actually look and find stuff within your tree, so as to have a way to find geometry, and it does that through these lists. So whenever you make a pattern, you have to put any geometry you generate into at least one of these lists. And basically, when the pattern makes any geometry, it'll put it both into the tree where you specify. So here, this is where I'm creating the first point. I'm saying put it into the generate geometry points 1. So it goes into this geometric set. And then the second one is I specify which list I want to put in, and put in list points. So you can create as many of these as you want. And then in your model, this becomes an object. And also within each knowledge pattern, there's a set of lists, and each list kind of holds this geometry. So if you see, if I pointer over this list points, it highlights those points. You can also double click and see all the geometry that's in that list. And that also gives you the size. So that basically allows the pattern to know where it's putting geometry, and it also allows other scripts later to access that geometry. Because if, say, you wanted, like I'll do in the second tutorial, a UDF to be instantiated in these points, and you can do that through another pattern, but you have to make it look for this list, basically, to find those points. So you can't look into a geometric set. You can only look into one of these pattern lists. Okay? So, let's see. So I'll just kind of redo this really quickly. The way I like to set this up, just to keep organized what's in the UDF, what's not, is to have a folder called geometric set construction geometry, where I'll put anything kind of that's going to be an input for the UDF. And then another one, set UDF, so this is all UDF geometry. And then the third folder would be geometric set instantiated geometry. Okay, so we start create this line. And then create this spline based on those points. Okay, that's kind of enough to get started. So then, to create a knowledge pattern, we have to go into the product knowledge template workbench, and this is the icon. Oh, you can't see the icon. Sorry about that. This is the icon to create a new knowledge pattern. First step is to make a list. So here, list points, and then we can start writing the script. So first, you specify your variables. So I will be the counter. So we specify that an integer number, and then we also have a variable for creating the point, which is be point, and that'll be a point object. And then the script basically will run in the loop and instantiate through a point constructor points along this curve. So if we declare I starting with 1, we start running a loop. So for I, while I equals smaller than, we just start with 10 points. And then all of the generative functions can be found in the dictionary. under generator functions, and it's these two basically are the most important: create a modified template or create a modified datum. So for datum geometry, we use this one, and you go through and see kind of what it needs for inputs here. So the first one is a string. It's the object name, which is point. That's the type of object that it's going to be creating. The second one is where in the tree you want it to be created, in this folder, and then the list. You can just double click on these things, and then the location, the index in that list. So basically you have to start with 1 and count up sequentially to put objects into these lists. Since we have I being this counter here, we can set that as I. And then, so once you kind of create this point virtually, you have to specify its location in space then. And you do that, for points, you do it through point constructors, and for lines, you do it through line constructors. And these are the two constructor things. And you can see here, these are all the ways in CATIA that you can create points. It's very similar to how you create points already in the geometry, but this is kind of more explicit how you do it in the script. So here we have to set, so point is our, PT is our point variable. So when we create the point, we set PT equal to this generator, and then we create the actual point in space by setting PT equal to one of these point constructors. Since we want circle, sorry, point constructors. Since we wanted to create points equally spaced along this curve, we'll use a point on curve ratio constructor. And then here you can see all the inputs. So first we specify the curve, we can double click it right from the geometry. The next one is the first point. We have that here. So you can always go back and check out these inputs. Then the ratio, and then Boolean. So basically, Boolean is set to true, and then the ratio is a bit of math, basically of how you want these points to be laid out. Since we have 10 points total, we can just set the ratio as I over 10. So each time it gets to this distance, it'll take whatever I is and put it another increment of over 10 along that curve. So 1 over 10, 2 over 10, 3 over 10. And then that should be it for that. And then here you can set it to automatic execution. So there it is. Basically we created 9 points along this line, and also put those points into this list points in here. And then to expand a little bit, we can create a global parameter, integer type, call it num points 5, and within the actual pattern we can use that num points instead of this integer, and we can get that by double clicking on it straight from the tree. And now the number of points we create will be controlled by this integer. Okay. Make sense?